Hello everyone, welcome you all to this video. So in this video, we will be trying to solve some numericals from the subject that is thermodynamics, and we will be morely focusing on the first law of thermodynamics applied to a process for any closed system, right? Okay. So before watching the solution, try to solve the question by yourself. Okay. After that, only try to watch the solution, right? So pause the video and try to solve by yourself, then watch the solution, right? Okay. So I'm starting. So this is the question number one, and it is saying the specific heat at constant volume for an ideal gas. It is given by this relation, right? So here Cv is equal to 0.7 plus 2.7 into 10 to the power minus 4 times T. Okay, and unit is this one, and we know this unit, right? So this is kilojoule per kg Kelvin, and obviously temperature will be in Kelvin, right? The change in internal energy for this ideal gas undergoing a process in which temperature changes from 27 degree to 127 degree centigrade in more clearly, right? That means we need to find out the value of change in internal energy. So हमको कौन करार अछि हमको internal energy केते change होछि सेटा बाहर करार अछि जदि गोटे प्रोसेस रे टेम्परेचर 27 डिग्री रु 127 को चेंज होछि, right? And for that process Cv value is not a purely constant. So in this process, during this process, the value of Cv it is dependent on the temperature, right? So directly we cannot write this is du equal to Cv dt, right? So we need to use this formula, but we will be integrating from state point 1 to state point 2, right? Because in this case, Cv is not a pure constant, it is dependent on temperature. So we need to integrate the value of Cv Cv into dt from step point 1 to step point 2, right? So जदि आम एतिक जिनस जानि दउछे then we can solve the question without any doubt, right? Without any confusion. So now let us put this value at the place of Cv. So if we will be doing that, we can write this is 0.7 plus 2.7 into 10 to the power minus 4 times t, and it will be dt, and we'll be multiplying from integrating from t1 to t2, right? And this is the simple integration we can say. So here this is 0.7 and t will be varying from t1 to t2 plus this is 2.7 into 10 to the power minus 4. Here this will be t square by 2, and temperature will be varying with t1 to t2. Okay, so now we'll be putting the values. So this will be 0.7, and here T2 is 127 degrees centigrade. That simply means we can write in the terms of Kelvin, this will be 400 Kelvin, right? And this is 27 degrees centigrade, so this can be written as 300 Kelvin, right? So 400 minus 300, we can write 100 over here, right? Plus 2.7 into 10 to the power minus 4, so this will be t square by 2, right? So t2 square, so I can write 400 square minus t1 square, that is 300 square divided by 2, right? So if we'll be doing this calculation, let me do it. So very quickly, 0.7 into 100, so we can this write down this is 70 plus this is 2.7 into 10 raised to the power minus 4 into this is 400 square uh, minus 300 square divided by 2, right? So this we are getting as 79.45, right? This is 79.45, and obviously kilojoule per kg, right? So approximately we are getting the option 3 the correct answer, right? 79.5 is the correct answer for this question. So hope it was understandable, right? So let us move towards next question, that is question number 2, right? So here is the question in front of you. Okay, okay, so let us read it clearly. So it looked like a big problem or long problem, but Obviously, it is not the difficult one. Okay, let us try to see and understand the question. And after understanding the question, it will take very less time to solve any question, right? Okay. So first, so here it is saying a piston cylinder arrangement is there. So obviously we can see from the figure. So there is a piston. This one is the piston, right? Okay. So let me use the pen, right? Okay, so here is piston is given to us, right? And this is the total cylinder, right? And some gas is there inside it, and this is one stirrer which is rotating inside this system, right? Okay, and some work is given to the system by the help of stirrer. Okay, okay, let us see and read the question what it is saying. So here a piston and cylinder machine is containing a fluid system, so that means there is fluid inside it, and has a steering device in the cylinder as shown in the figure, right? The piston is frictionless, so that means simply we need to neglect the friction, and it is held down against the fluid due to the atmospheric pressure, and it is given this much, that is 101.325, it is the atmospheric pressure, right? So here it is written, right? 101.325, right? So this steering device is turned up to this much revolution, 5000 revolution, with an average torque against the fluid, that is this much, right? 1.275 Newton per meter, Newton meter, right? That means joule we can say. And meanwhile, the piston of diameter this one 0.6 meter, and it is moving out of this length. So this much movement is taking place. That means from here to here, this distance is we can say 0.3 meter, right? And we need to find out the magnitude of net work, right? So we have to find out the net work interaction. So जदि आमे देखिबा एठी दीटा वर्क इंटरेक्शन होउची गोटे ए स्टारर जोगु, दैट मींस स्टारर जोगु आमे किछि वर्क दउचे सिस्टम को, एंड जेतेले पिस्टन ता मूव करूची ए पॉइंट टू ए पॉइंट को, so during this displacement we are getting some amount of work from the system, right? So that means some work is given to the system by the help of this stirrer. Okay, and we are getting some amount of work from the system due to this piston movement, right? And we have to find out the value of this net work, right? Okay, so simply we can write down the network. Before that, let me tell this is as w1 and this is as w2. So we can see that this is the amount of work is given to the system, so we can consider this is as the negative, and this much amount of work we are getting from the system, so this can be considered as positive. So during the calculation of net work, w net can be written as w2 minus w1, right? So individually we will be trying to find out the value of w2 and w1, and if you individually we can find out, then simply we can find out the value of net work, right? Okay, so let us try to find out the value of W1 first. So W1, that means how much revolution is taking place, or revolutions is being done by the help of stirrer, that is 5000, right? So we can say this is the value of n. So n revolution is taking place, and due to during this n revolution, how much torque is there? This much t. Let this is the t value, right? And if we know the value of n and t, then we can find out the value of w1, that will be equal to 2 pi times nt, right? And 2 pi, these are the constants, n is given, that is 1.275, and t is sorry, this is the value of t I wrote down, so n will be, this is 5000, right? So it will be calculating this, so this is 2 into pi into n, this is 5000 into 1.275, so we are getting as 40055, this will be joule, right? And if we be trying to calculate in terms of kilojoule, this will be equal to nearly 40 kilojoule, right? So this is the value of W1. Now we will be trying to find out the value of W2, and W2 is the displacement work, so WD we can say, and this will be equal to pressure times multiplication of dV, right? Change in volume. So here pressure is the constant, we can say during this displacement pressure will always remain constant. Okay, so due to this addition of work, the pressure is going to increase inside the system, and due to this increase of the pressure inside the system, the piston is moving towards right. So due to that, pressure will decrease. So pressure increase and decrease, increase and decrease. So this will be happening continuously. So inside this process, during the process, pressure will be remaining constant inside the system. Okay, so out there ମୁଁ କହି ଦଉଛି ଆମେ କଣ କରୁଛେ ଆମେ କିଛି work ଦଉଛେ starter ରେ, so that ବି ଏଇ ଭିତରେ ଯୋଉ system ଅଛି ଯୋଉ gas ଅଛି ତାର pressure ସବୁବେଳେ ବଢିବାକୁ ଚେଷ୍ଟା କରିବ, right? So pressure ବଢିଗଲା, then due to this increase in pressure, right, ଭିତର pressure ବଢିଗଲା ତ ତା ମାନେ ଭିତର side ରୁ, right, so rightward force which was previously equal to the leftward force, now that force is being increased, right? So due to this increase in force, our piston will be shifting towards right. So piston ଆମର move କରିବା start ହେବ, ତ ସେ ପର୍ଯ୍ୟନ୍ତ move କରିବ ଯେତେବେଳେ ପର୍ଯ୍ୟନ୍ତ ଆମର ବାହାର ଫୋର୍ସ ସହିତ ସମାନ ହେଇନି। ତ ଯେତେବେଳେ ସମାନ ହେଇଯିବ ପୁଣି କ'ଣ ହେବ, piston ଟା ରହିଯିବ, right? So ଏଭଳି continuously ଯଦି ଆମେ କହୁଛେ process ଟା ହଉଛି, then we can treat this as a quasi-static process and the system pressure will be remaining constant, right? So in this case we can say that pressure is remaining constant and this pressure will be the atmospheric pressure, and this volume, so change in volume we can calculate. We know the value of this diameter of this cylinder and the displacement which is also known to us, so we can find out the value of this change in volume, right? So this will be equal to, pressure is 101.325 and dV will be equal to pi by 4 d square, so this is 0.6 square into 0.3. so it will be calculating this, so let us calculate that. 101.325 into pi by 4 into 0.6 square into 0.3, so we will be getting as 8.59. obviously it will be in terms of kilojoule, okay, and W net, that will be equal to W2, that is 8.59 minus this 40, so this will be equal to 8.59 minus 40, so that will be equal to 31.41, obviously minus, so 31.41 kilojoule. This will be the net work for this system, right? So this will be negative. Okay, so I hope it was understandable. Okay, so try to see the solution again and solve the question, right? Okay, so let us move towards next question, which is the question number 3. So let us read it. Here it is saying that consider two closed systems, one is A and B, and system A contains this much, that is 3000 kg of thermal energy at 20 degrees centigrade, and system B contains 200 kilojoule of thermal energy at 50 degrees centigrade. So if I am saying this is system A, so it is having 50 degrees centigrade, sorry, so it is having 20 degrees centigrade, right? So this is 20 degrees centigrade, and if this is the system B, then this is having 50 degrees centigrade, right? And it is having 3000 kilojoule of thermal energy, and it is having 200 kilojoule of thermal energy, right? So when they are brought into contact with each other, we need to find out the direction of any heat transfer between these two systems, right? So we know that the heat will always try to flow from the higher temperature region to lower temperature region, right? So this will be the direction of heat transfer, right? So option number 2 will be the correct answer for this question. Okay, so I hope there is nothing to talk about it in this question. So simply it will always flow from the higher temperature region to lower temperature region, right? Let us move towards next question, which is the question number 4. So here it is saying that 4 kg of certain gas, okay, so here 4 kg, this is the mass of the gas, and it is contained within a piston cylinder assembly, and this gas undergoes a process in which pressure and volume with a relation is this one, right? So here we can say this is the polytropic process, right? This is, let me write it, this is polytropic process, and for this polytropic process the value of n is equal to how much? So n equal to 1.5. so this much data is given, right? So initial pressure is given 3 bar and volume is given 0.1 meter cube, v2 is given 0.2 meter cube, right? So p1 is given, p2 is not given, right? So this is not given, and v1 is given and v2 is also given, right? So U2 minus U1, that is also good, right? The change in specific internal energy of the gas during the process is given, that is minus 4.6 kilojoule per kg, right? So there are no significant changes in kinetic energy and potential energy. That means del Ke and del Pe can be neglected at 0. That means we can write del Q is equal to dE, right? So dE plus del W. So this equation can be written as del Q plus, so not plus, that is del Q is equal to dU plus del W. Simply we are neglecting the change in kinetic energy and potential energy, so dE can be written as dU, right? Okay, so during this process we need to find out the net heat transfer, right? So here du value is simply given, and that will be equal to n times this u2 minus u1, which is given to us, u2 minus u1, right? And if we can find out this value of del w, then del q can be calculated, right? So now let us try to find out the value of this del w, and for polytropic process we know this is p1 v1 minus p2 v2 divided by n minus 1, right? But here P1 V1 is given, no issue. V2 is also given, no issue. But P2 is not known to us, right? So let us try to find out this value of P2, right? So we know this is P1 V1 to the power n equal to P2 V2 to the power n. So here P2 can be found out as P1 multiplied by V1 by V2 to the power n, right? And here P2 can be found out as how much? This P1 is 3 bar, right? So P1 is 3 bar into V1 is 0.1 divided by 0.2 to the power 1.5. So if we'll be solving this equation, then we will be finding the value of P2, that will be equal to 1.06 bar, right? So now there is nothing to calculate, simply we'll be putting all these values over here and we'll be trying to find out the value of del W. So del W will be equal to what? So del W will be equal to P1, that is 3 into V1, that is 0.1 minus 1.06 into this is 0.2 divided by 1.5 minus 1. So if we be calculating this one, let us calculate 3 into 0.1 minus 1.06 into 0.2 divided by 0.5. So here we are getting this as 0.176 into 10 to the power 5, right? So this is here bar, so that means 10 to the power 5 will be multiplied and this will be joule, right? And if we will be trying to write this in terms of kilojoule, then we can write this is 17.6 kilojoule, right? So now we have to find out the value of del q. So del q will be equal to what? Du, that is m, that is m is given 4 over here, and u2 minus 1 is minus 4.6, and here plus this is 17.6, and here 4 into 4.6, that will be equal to minus 18.4 plus 17.6. So here 18.4 minus 17.6. So here we'll be getting the net heat value, that is negative 0.8 kilojoule, right? So net heat transfer will be equal to minus 0.8 kilojoule. So this will be the answer for this question. Hope it was understandable. So let us check it again. So how was the question? So uh, here we need to find out the value of this one, right? So we had to find out the value of day q, and we were given with the value of du, that is specific internal energy change, right? And if we will be multiplying with this mass, then we can calculate the value of this du, and then we had to calculate the value of net work interaction. And for work interaction, this is the formula, that is P1 V1 minus P2 V2 divided by n minus 1. So here P2 was the unknown, and from here we found out the value of P2, and after finding the value of P2 we put over here and we calculated the value of del W, and from here we calculated the value of del Q, right? So this is how we solve this question, right? So let us move towards the next question, and this is the last question for this test, right? Okay, so let us read it. So here it is saying that a piston compresses 1 kg of air, so that means m equal to 1 kg inside a gas cylinder arrangement, right? Sorry. So here air is there, and this is the piston and this is the cylinder. We are compressing it, right? Okay. So the rate at which the piston does work, that is this one. That means piston is compressing the air. So W is given to the system, and this is the rate. So W is given 3000 watt, right? So at the same time heat is being lost through the walls of the cylinder at the rate of this one. So during this time some heat is being lost, and this is let Q, and this is given over here, right? So given that specific heats of air, Cp and Cv values are given, and we need to find out the change in temperature of air after 10 seconds, right? So del T value we have to calculate after after 10 seconds, right? Right. Okay, so again we have to apply the first law of thermodynamics over here for the process when uh, the state properties are changing from the state point 1 to state 2, right? So del q will be equal to again du plus del w, but this all these terms should be written in the form of rate. That means we can say del q dot plus du dot plus del du dot, right? Okay, so this value is given, this value is given. So let us talk about the sign over here. So here W is given to the system, so this will be the negative sign, right? So 3001, 3000 watt, it will be put it with a negative sign, right? And again heat is being lost from the system, so this will be put it in with a negative sign here, right? Okay, so let us try to put all these values. So here del q dot will be equal to how much? This is 8 47, right? 847.5, and that will be equal to du can be written as mcv del t divided by t, because we are writing on this equation in the form of rate, time rate. Okay, so this t is the time and this is the temperature, plus del w. So here it will be with a negative sign, and here it will be also with a negative sign, 3000, right? So here cv is given, that is 717.5, and mass is given 1 kg, and this t is given 10, right? So del t will be equal to what? 3000 minus 847.5 divided by 717.5 into 10. So if we'll be doing this calculation, so let us do that. So 3000 minus 847.5 divided by 717.5 into 10. So we are getting as this is 30 Kelvin, right? So option number 3 will be the correct answer for this question. 30 Kelvin will be the correct answer for this question. Okay, so we try to solve some questions within few minutes. Okay, So around we consume 25 minutes over here. Okay, so try to solve many more questions as much you can. Okay, jate parucho question solve karo. If you are facing any doubt, then you can ask.